Okay, so yeah, well, sorry. Yeah, so again to repeat that. Now for the assignment number 3, as I mentioned, we're going to have two sets of the question, the question number 1 and the question number 2. You have to read actually who can do this one and who can do the other one. What we find here is a shaft with the 3 pulleys has been uh, jointed to, that they provide the movement transfer from one side to another. Of course, we're going to have one is going to be the input, the other two is going to be the output. The belt on the pulley is going to cause a force, and this force is going to be in the direction of the force input or output. So what we have in these 3 pulleys, we're going to have at A, the force going down, at B, the force going up, and the C, the force going down. We're going to add 2 bearings at the D and the E to make a reaction to keep the shaft rotating and in position. The value for the allowable stress for the shaft is given here by this equation. An example on how to calculate your allowable stress is given here. For example, it's going to be equal to, wait a second, I use 110 here. I think that the final one is quite different. Anyway, follow that, don't follow this one. This is just an example, okay? Yeah, I think there's a typo here. This should be 110, this should be 110. Okay, so the forces here can be calculated by using these equations. The x and the y are the last 2 digits of your student number. The steps will start by following the example we're going to see next from the week 8. Just remember that here we don't need to find the maximum diameter. We need to find the minimum diameters at every sections, A, D, B, C, and E. It's not going to be a rocket science. It's going to be following this example. We're going to sketch the free body diagram, finding the reaction at A and B. We can find the reaction at A by taking the moment around B to be equal to 0, find the RA. Sigma all the force in the y direction, you will find the RB. Done. Now we are going to start to do the cutting of the sections. The first one in this example, you know where you can find this one? That's tutorial for the week 8. Okay. Now we're going to make the first section between the A and the D, find the bending moment between A and the D. The X value maximum is going to be 250. Then make a section between the A and the, sorry, D and the B. So the maximum X is going to be 500. Distance between the D and the section is going to be X minus 250. Now, the other section is going to be between the B and the C here. Okay, you can either do it from that side or you can do it from the other side. Which one is easier for you? It's up to you. So once again, you can either make the section between the B and the C or the C and the B. It's going to be cut here. You want to analyze it either way, it's going to be okay. Okay, then you can find the bending moment here, and the X value maximum is going to be either the 900, or you can do it that way, which is going to be 550. Okay, now you can find also the reaction, the bending moment between the C and the E section. Come back to this one. We found the reactions. We start to do the sectioning. Here we did the section here, find the bending moment for the X value maximum to be 0.5. Then we did it here. We find it with the X value maximum to be 0.9. Then we did on the other side, and to do that, because we are going to have an extra pulley here, so you can start do the section between the A and the D, between the D and the B, and then you can start from the other side to find what will be the moment on the other direction. After you got all these informations, build your bending moment diagram, the M against the X. So here you can find that we started with the bending moment of 0, the bending moment of 0 at the end. In real life scenario, it's not only the bending moment, but also the torque is going to be involved. So actually, the actual equation of the bending of the diameter of the shaft is going to contain both components. Here we don't, we're not going to include the torque. So we're going to depend on the bending moment. And what we are going to do is we're going to calculate the minimum diameter at D, at B, at C. The diameter at E at the end of the shaft is going to be equal to the diameter at, I'm talking about this one. So diameter at E is going to be equal to diameter at C, it's not zero. And diameter at A will be equal to diameter at D, which is, once again, shouldn't be zero. No zero diameters and no negative diameters. Just remember that. Now, the equation for the diameters, I will expect you to write down the derivation of that equation. Don't simply just use that equation to do your calculation. Okay, so that's it. Now the recording should be available for you. And it should be actually available in 5 minutes.